Hello, my name is Danielle Enriquez, and this is my update presentation for my Advanced Analytics Practicum, Predicting Transfer Student Performance. Here's a quick look at my agenda and what I hope to accomplish in this presentation. A quick review of my project goals. As I previously stated, the off-campus advisors have never tracked performance on a longitudinal basis. We're hoping to achieve a better understanding of how students are performing off campus. So we're looking to answer some of these questions. I also performed a brief exploratory analysis for pattern detection and further hypothesis analysis, which you'll be seeing in upcoming slides. The second part of my project involves predictive analytics, predicting whether an off-campus transfer student will pass/fail the term. A passing term is a 2.0 or better. I will be creating two models based on varying data sets, which I'll explain in a moment. I did complete a final data cleansing, standardizing semester codes, establishing a primary key for the term data, standardizing SEEB, which is the transfer sending school code. I also created new features for both the dataset 1 and dataset 2. These are largely numeric. The numeric fields will be used to help better balance the data models. And finally, I did aggregate the on-campus and online courses. Okay. As I previously mentioned, I'll be working with two datasets. So the first dataset has more features but less terms. This basically represents the more recent, newly acquired data fields. So I'll have 27 total attributes, 3 terms, and 1,111 instances. The second data set has less features but more terms. This goes back to fall 2011, so I'll have 10 terms, 19 total attributes, and 8,296 instances. So I first began working with Tableau in 2008 as part of a data visualization course. This is really a mile-high view of the overall distribution of the pass-fail rate by location. So here you're looking at Atlantic Cape, which had the highest fail rate. Brookdale, which has the largest student population. Mercer is one of our more recent or newer locations. Morris is our most recent location, so it has the smallest student population. Followed by Raritan Valley, and a quick data table showing the pass-fail distribution across the 5 locations. And you'll notice the data skew. The data is clearly unbalanced, which I'll be addressing in upcoming slides. I also wanted to provide a snapshot of a felony analysis. So I did run the numbers, and out of all records, felonies only represented 6.84% of this sample population, out of which 91.89% did pass. Additional data insights using Tableau. I wanted to provide a few scatter plots that address student preparedness. During the advisors' discussion, we hypothesized regarding a few admissions timeframes and whether they are related to student success. So here, this scatter plot basically shows pass-fail. The fail is in red, passing is in gray, and it represents the time frame of AD to AC, which is admit status to admit coming status. In a nutshell, this is how quickly a student may have clicked the button and indicated they are interested in attending Rutgers once they were admitted. And we hypothesized that a student that is quicker at clicking this button is more prepared for the term. As you can see, this chart does support that hypothesis. Here you'll have that same breakdown, but the colors represent the various locations. You will notice that Morris and Mercer don't support that pattern of the faster they click the button, the more likely they are to succeed. The second scatter plot that we looked at addressing student preparedness is the time lapse from admissions to the term start. So we expect this to be a longer period of time. This really addresses how early an application is submitted. So again, you'll notice that this chart does support the hypothesis where the longer time frame the student is more likely to pass the term. And again, you'll see Morris does not support this pattern, with the failing rate being much further to the right of the passing, which is represented by the red box for Morris. Finally, looking at the time lapse from app submission to AD status, and this really addresses how quickly the admissions staff rendered the admissions decision. For the most part, the quicker an admissions decision is rendered really does speak to how well the student may have previously performed. So one would hypothesize that these students would also perform well when, once arriving at Rutgers. Actually, you'll see here this chart does not support the hypothesis, and here you'll see down below that Mercer and Brookdale really are the only ones that are reflecting this pattern. I wanted to show a few visualizations as additional descriptive analysis. Quick bar plot chart, and you'll notice there are two majors, 135 and 537, which is business and hospitality management, which are showing a relatively lower passing rate. A quick breakdown by gender, with the females slightly outperforming the males. A breakdown by ethnicity, with the varying ethnicity codes, with the scale being the GPA there on y-axis. And finally, a dot plot chart with the entry levels, which we'll jump into a bit further in the next slide. I also wanted to just list some of the libraries that were used for part of the analysis. Okay, so a dot plot chart with entry levels, you'll notice 4, 5, 6, and 7. This was really interesting. The off-campus advisors assume that students coming in with an AA degree, AS degree, would be more prepared for the term and have a higher success rate. However, here you'll notice that that's not the case. The AA degree and AS degree holders actually have the highest failing rate among the various entry levels, and by that time their application has been submitted. So in this case, it could be the students that are out of school for quite some time that are coming across as AA degree holders. That would better identify the students that are actively enrolled from those that may have taken a few terms off. Quick look at some of the data models I've begun to create with dataset 1. The data set, the 1,111 instances, as you previously saw, were highly unbalanced. So I applied some balancing techniques, and I was looking to basically work with the random forest trees and SVM models. Here's a quick look at the results of the three models, starting with classification regression tree, random forest, and support vector machines. Support vector machines actually perform the best. However, I question what's going on here, having such a great success rate. I was wondering, am I overfitting? You know, I wasn't expecting this type of result. And in doing further research, I made a silly mistake. I included GPA term in the data set, which of course would be a very good predictor for whether the student would pass, fail. So I really need to remove that feature and reanalyze the three models. Okay, so for my timeline, pre-processing is basically done. The model testing and selection for data set 1, although I've gone through one set, I really need to retrain data set 1. And I also have to do all of this again for data set 2, which is prepared, it just has to be evaluated and analyzed. And then finally, testing and validation for both data set 1 and data set 2. And my time log.